The shocking story of how 3 bombers obliterated Japan's Invincible Akagi. At 8:22 a.m. on June 4, 1942, a 1,000-pound bomb punched through 3 inches of armored decking and vanished into the belly of the aircraft carrier Akagi. For 4 seconds, the ocean held its breath. On board, men had no idea what was about to unmake their ship. Then the hangar erupted inward, an inferno that did not begin with that single bomb so much as it answered a dozen smaller and avoidable mistakes that had been stacked like kindling. The world's most celebrated carrier, the flagship of the Kido Butai, ceased to be a ship. That is the moment the story fixes on. But the true shock asks a different question. How did an invincible carrier come to wear its own pyre? To understand the answer, we rewind 94 minutes and follow the thin thread of decisions, procedures and improv that turned a tactical opportunity into tactical catastrophe. At 7:28 a.m., a Japanese reconnaissance plane relayed a 9-word report. An American carrier force had been sighted where none was expected. The message slid across Rear Admiral Chuichi Nagumo's bridge like an incendiary fuse. Nagumo, commander of the Kido Butai, faced a razor-edged dilemma. How quickly could he arm his aircraft for the mission his commanders thought likely, and how much risk could his carriers accept if he changed plans? The Kido Butai had launched early in the morning with the expectation that American airstrips on Midway would need to be silenced. Many of the strike aircraft were already armed with land bombs. 1,000-pounders meant to pulverize runways and enemy hangars, not with the Type 91 torpedoes specialized for sinking warships. Calling for rearming meant exposing aircraft, ordnance and fuel to procedures designed for calm, not for the sudden clockwork of fleet action. Nagumo's choice was constrained by time and intelligence. He could launch immediately with the current loadout and hope the enemy was vulnerable to high-altitude bombing. Or he could order the rearming of his squadrons, remove land bombs, install torpedoes and armor-piercing bombs, an operation that would unfold in the hangars below deck and could not be rushed without breaking crucial safety protocols. According to contemporary reconstructions of the morning, Nagumo chose the middle ground. He ordered rearming. It was a defensible military judgment given the information he had. It would also set the stage for disaster. To see why, it helps to look inside the carrier, below the glossy flight deck and the drama of pilots braced on account dials. The hangar is the ship's vulnerable workshop, long, cluttered, noisy, edged with elevators that move aircraft and ordnance between decks, threaded with fuel lines and ammunition trolleys. Under normal operations, live ordnance would be kept in armored magazines well below the hangar. Bombs and torpedoes moved onto the hangar floor only under tightly controlled procedures. Fuel supply systems were normally secured when ordnance handling was in progress. Those safeguards existed because the physics of fire aboard a carrier are unforgiving. Aviation gasoline sprays, vapors collect, and a single ruptured line can turn a deck into an accelerator for detonation. On mid-morning, Akagi and her sister carriers were moving against time. Men below decks began to strip bombs from returning or spare aircraft, lay them on trolleys, and move them to points where they could be fitted to other planes. Torpedoes were being readied. Fuel hoses were uncoiled and connected to service points. Contemporary accounts from Japanese officers note the pressure. Planes had to be rearmed and relaunched within minutes if the Kido Butai was to seize the tactical moment. The crew improvised, and deviations from procedure multiplied. Under time pressure, people make different choices, an ordnance specialist explains on camera. Bomb crews, who'd trained for routine transfers, was suddenly performing heavy handling in a crowded, moving space. Instead of returning bombs to the armored magazine, an operation that would cost time, they were left staged on trolleys in the hangar and on the elevator deck. Fuel hoses, which should have been disconnected and drained whenever ordnance was present, remained hooked up to service lines. That combination, exposed ordnance, live fuel, and open access to elevators, creates a very dangerous environment. It's like putting a lit match into a gas station. The danger was not merely theoretical. Japanese naval doctrine recognized that a carrier's greatest vulnerability was not a shell from an enemy cruiser, but a mistake that turned stored explosives and fuel into a chain reaction. Lieutenant Commander Minoru Genda and other staff officers had argued for stringent procedures, but doctrine and reality often arrived on different schedules, and Nagumo's rearming order was an operational compromise that left the ship with weaknesses it could not absorb. Meanwhile, the American side was closing fast on its own set of narrow fortunes. Lieutenant Commander Wade McCluskey, flying over the sea in a dauntless scout plane, spotted a destroyer's wake and followed it. That wake led inexorably to the 4 Japanese carriers sailing in formation. At the same time, the Japanese Combat Air Patrol, its fighters, had been drawn down low to counter previous torpedo attacks, leaving the carriers thinly defended at altitude. The moment McCluskey's scouting plane found the fleet, American dive bombers at altitude had a clear, unmolested approach. Lieutenant Richard H. Best, a pilot in Fighting Squadron 6 aboard the U.S. carrier Enterprise, found himself in the center of that set of converging advantages and perils. Best and 2 other dauntless pilots were assigned to attack Akagi. What followed was a dive bomber's choreography. The aircraft pitched into steep, near-vertical dives, the pilot hanging on while the airframe punished muscle and instrument, the rear gunner scanning, and the bombardier keeping a steady eye on range. The dive bomber is a precision weapon, not a brute force missile. Its damage comes from the kinetic energy that carries a bomb through thin deck and into the vulnerable spaces below. Best's 1,000-pounder struck the flight deck, smashed through the hangar barrier, and disappeared into the darkness below. For the men in the hangar, it was a single, incomprehensible concussion. For those above, it was the moment when a cascade might begin. But before the cascade could occur, the confluence of human choices, physical fragility, and ordnance proximity had to be laid out. Witness reports later reconstructed a hangar space filled with stacked bombs on trolleys, torpedoes mounted on cradles, and fuel hoses running to service points. Elevators were mid-cycle. Damage control parties had not yet secured bulkheads. In short, the carrier had assembled many of the components of a catastrophic fire, and those components only needed a catalyst. Bombs sitting on trolleys, fuel flowing in service hoses. This is textbook for a catastrophic cook-off, says a naval damage control expert. When fuel sprays and ignites, it doesn't just burn, it spreads over the deck, into compartments and through ventilation. If warheads or other bombs are cooked by fires, you get sympathetic detonation. One device sets off another. That's what takes a single penetration and turns it into a near-simultaneous series of blasts. The structural effects are brutal. The overpressure tears plates outward, elevator systems fail, the flight deck can separate from its supports. It's not just a fire, it's an internal demolition. Back on the bridge, Captain Tetsuro Aoki and other officers were attempting to assess a situation they could not see. The standard chain of reporting had not yet provided a clear picture. Genda, who had warned of the vulnerabilities, walked the decks and saw the hangar's dangerous loadout, but could not instantaneously reverse the processes underway. Nagumo, as a commander, had limited options. He could have ordered aircraft launched in current configuration and avoided rearming, but that risked leaving torpedoes in hand where they might be less effective, or he could order rearming and trust his crews. The choice had already been made. While this procedural tapestry was being woven, the American dive-bombing groups were lining up and diving. The air was thick with concentration, the dauntless pilots staring down the edge of the world, trusting a fragile machine whose entire purpose was to deliver ordnance with exacting timing. The 2-minute window between sighting and attack turned on tiny decisions: altitude choices, deflection angles, release points. Best flew as he had trained, dove as the instruments and his muscles demanded, and released his bomb precisely where physics promised greatest damage. There is a temptation in storytelling to make heroes into singular beings who cause epochs of change with one decisive act. The record resists that temptation. What Best did was precise and consequential. What turned his success into catastrophe was not merely the bomb, but the cluster of conditions already present on Akagi. He was the match that, in a hangar already stacked with tinder, could not help but start the blaze. The first detonations happened below deck, but the real horror was how quickly the ship's internal systems failed to contain the violence. Fire turned to blast and blast to structural collapse. Survivors later described sudden, overwhelming heat, decks buckling beneath their feet, men thrown like toys when plates gave and supports failed. Rescue efforts were hampered by the very systems that had been intended to make the ship resilient. Elevators jammed, hoses ruptured, bulkheads failing to hold. Within minutes, Akagi was no longer a platform for launching aircraft, but a burning ruin. At nearly the same time, other carriers in the Kido Butai, Kaga and Soryu also came under attack. Their own arcs of vulnerability and misfortune echoed Akagi's. In the span of a few hours, what had been a concentrated, seemingly immutable carrier group lost its cohesion and several capital ships. In the wake of smoke and torn steel, the human cost was staggering. More than 1,700 Japanese sailors were killed across the carriers that morning. Those are numbers to be borne with solemn respect, not used as rhetorical trophies. In Tokyo and on the bridges of other Japanese ships, the immediate response was confusion, damage control, and eventually, crisis management. What followed in the weeks and months to come would be a mixture of forensic study, doctrinal reappraisal, and engineering change. Navy officers convened inquiries to understand how an attack with apparent single origins could cause such multi-point devastation. Reports emphasized rearming procedures, fuel handling protocols, magazine security, and the design limitations of carrier hangars. Those lessons would be learned the hard way. On the American side, the victory at Midway, the battle of which this morning was the fulcrum, was not only fought with planes and pilots, but in the back rooms of intelligence. Commander Joseph Rochefort and his team had produced the critical intelligence that made the encounter possible. Decrypts and syntheses that pointed the American carriers toward the Japanese. That intelligence advantage was fragile and contested. After Midway, inter-service politics and bureaucratic rivalries would curtail Rochefort's influence, a development that some historians argue dulled American advantage in later intelligence campaigns. The interplay of battlefield success and bureau shuffle politics is a sobering reminder that strategic wins depend on less glorious administrative stewardship as much as on heroics in the sky. For the remainder of the morning, the sea took back what the fleet had given. Men abandoned ship, rescue boats skirted flaming wreckage, damage control parties fought to keep what they could. The carriers that remained afloat had been dealt wounds that would change the course of their navy, and by extension, the wider war. The tactical map of the Pacific had shifted. If you want the next part, where we go inside Tokyo's reaction, examine the code-breaking drama in depth, and follow how those choices rippled into campaigns from Guadalcanal to the Philippine Sea, subscribe and follow along. But before we leave the deck of Akagi that morning, we need to return to the hangar one last time and listen to what the sailors saw and what the ship told its survivors. The scene below deck is the doorway to the wider story. Procedural failures, human improvisation under stress, and the particular geometry of a weaponed hangar waiting like a wound. Men who lived through it later wrote terse accounts, deck logs, dispatches, and interviews that historians have stitched together into a minute-by-minute reconstruction. Those fragments reveal how ordinary tasks, stopping for fuel, moving a bomb from trolley to wing, became stitches in a tapestry that would not hold. An ordnance crew chief later reported that, by the time of the attack, torsion bolts were in varying stages of attachment, and stacks of bombs lined the hangar where they might have been moved to magazines more safely under routine conditions. A maintenance petty officer recorded, in plain language, that fuel hoses were in service and that elevator traffic had been heavy. These are not dramatic flourishes. They are the mundane building blocks that, when multiplied, become lethal. From the perspective of ship design, the hangar is an efficient but dangerous compromise. It concentrates aircraft maintenance and ordnance handling in one long space to save time and weight. That design economy reduces the mass of structural armor you can afford and relies instead on procedure and human discipline to keep danger at bay. When procedures fray, even slightly, the structural compromises of design reveal themselves painfully. As the Dauntlesses wheeled away and the order to attack echoed back across the sky, Akagi's crew had no inkling of the forensic conclusions that would be drawn after the fires cooled. That a chain of internal detonations, not a single external explosion, produced the outward tear patterns inspectors would later note in photographs and survivors' descriptions. Those physical signatures are central to later debates among naval engineers and wreck forensic analysts. For now, the witness accounts are raw, pain and loss, the disorienting roar of fire, the sudden absence of an ordered life aboard ship. In the first hour after impact, damage control parties fought with the instruments available, hoses, pumps, sand, and sheer manpower, to keep fires contained. But the sequence of detonations and the spread of fuel-fed blazes overwhelmed their capacity. Pumps failed, crews were driven back, bulkheads could not be sealed, and the flight deck bowed under internal pressure. For many men, survival boiled down to one primitive choice: get off the ship or be consumed by it. It is tempting, in the calm interval after the action, to assign moral categories: negligence, improvisation, heroism. The reality resists simple labels. Men improvised out of necessity. Leaders made decisions in imperfect information environments. Nagumo's choice to rearm was not, on its face, irrational. It was a decision made under uncertainty. The tragedy lies in the way the decision interacted with fragile systems, with fatigue, with the pressure of tight timelines, and with a set of procedures that were brittle when stressed. One of the most haunting aspects of the morning is that tactical innovation, what some pilots called boldness, was punished and rewarded in the same breath. A pilot's precise work changed the tactical landscape. The systemic rigidity aboard the carriers allowed that work to have outsized lethal consequences. The tension between frontline innovation and institutional inertia is visible in microcosm on Akagi's decks that day. As the sun climbed and the smoke eddied across the ocean, the wider implications of the morning began to register on both sides. The Imperial Japanese Navy lost irreplaceable veteran air crews in addition to ships. For a force that prized trained pilots and tactical cohesion, that loss cut deep. The United States, meanwhile, learned lessons that would be transformed into doctrine and hardware over the bitter year that followed. Radar procedures, fighter control, pilot training throughput, these were the levers the Americans would pull to convert strategic advantage into operational dominance. On the Japanese side, the morning forced immediate engineering and procedural changes. New guidelines for rearming at sea, revised fuel handling protocols, and urgent studies about hangar vulnerabilities. And yet the story did not stop at doctrinal memos and shipyard directives. For the individuals involved, sailors, pilots, ordnance crews, the morning was an irreversible life marker. Lieutenant Richard Best would survive physically but carry pulmonary damage for the remainder of his life. Others would never return home. Akagi's carrier deck, once a symbol of projection and power, now lay as a demonstration of how complex systems fail. slowly at first in decisions and discipline, then instantly in explosion. From the vantage of history, this is where the narrative must linger for a moment, in the gap between a tactical act and a strategic consequence, in the human choices that make technical systems dangerous, and in the quiet moments when staff officers and petty officers alike recognize the faults too late. The shock of Akagi's destruction is not reducible to a single bomb, a single pilot, or a single order. It is the product of an alignment of errors and opportunities, of doctrine and improvisation, of human endurance and institutional limitations. Soon after the fires, inquiries would begin. Engineers would sketch cross-sections of hangars, reenact sequences of fuel flow, and calculate the propagation time of fire to ordnance. Historians would pass radio logs and the minutes of command decisions. Intelligence analysts would tally how decrypts had shaped the engagement and how political friction in Washington and Pearl Harbor affected the flow of information. The wreck of Akagi would, many decades later, offer an additional piece of evidence, but that is a chapter for the next installment. For now, the ship's bell tolls in memory. Men who had once stepped briskly across the flight deck now clung to life rafts, to floating debris, to the testimony of rescue crews. The carriers that remained were altered irreversibly. The Japanese Navy would attempt to adapt. The Americans would try to exploit what they had learned. The morning had been decisive in ways both immediate and slow, and its lessons would be written in policy papers and in the everyday practices of sailors for years to come. But there was one more technical truth pressed into that morning's geology. The timing between bomb impact and full-scale inferno was not measured in minutes. It was measured in seconds. In those seconds, the physics of a hangar, fuel spray, ignition, sympathetic detonation decided the fate of a capital ship. To understand those seconds fully, we must return to the weapons themselves, how a 1,000-pounder behaves under deck, how torpedo warheads react to thermal shock, and how a hangar compartment channels vapor and flame. Those are the subjects of laboratory simulations and of the naval engineer's worst nightmares. They are also the precise mechanics that make the difference between a near miss and the end of a ship. As the survivors were put on boats and carried away from the wreckage, as Akagi burned and went down to the sea, the naval staffs on both sides began theorizing like surgeons after the operation. What to change, what to repair, and how to prevent recurrence. That clinical debate would unfold into reforms, into new training programs, into altered carrier architecture. Yet institutions do not change quickly. They change in fits and starts, and often only after loss so visible and costly that inertia breaks. The human stories deserve to be tracked through that institutional conversation. Lieutenant Richard Best's trajectory, from that dauntless cockpit to a hospital bed and then a quiet civilian life, captures both heroism and the way heroism is absorbed into larger historical processes. Officers like Gender would argue, before and after the battle, about tactical innovation. Men on the hangar deck would be remembered as nameless victims in totals and memorials. Commanders would defend their choices, critics would assess them through the safety of hindsight. All of that is part of the morning's afterimage. We leave now on the edge of a deeper inquiry. The immediate mourning, the dive, the penetration, the brief, terrifying moments of silence has been unfolded. The next act will look at the institutional consequences in Tokyo, the wartime intelligence currents in Washington, and a later, surprising piece of physical evidence that would only emerge when human technology could not only chart, but touch what lay on the ocean floor. For the moment, the sea remembers Akagi's last day in a way that the men who stood on her deck could not. The wreck's contours, later traced by submersibles and ROVs decades after the smoke and grief had faded, would raise questions consistent with survivors' testimonies, patterns of outward tearing, signatures of internal blasts, and the geography of collapse. Those forensic hints would affirm part of the lived story, that a single bomb was the spark, but they would also show how complexly the ship's fate was written into its own design and the decisions of the morning. When we come back, we will go deeper into the intelligence that set McCluskey on course, the minute-by-minute calculations on Nagumo's bridge, and the hard lessons naval engineers took away from the ruin. We will trace how that morning rippled through Guadalcanal and to the Marianas, how doctrine and industrial might turn attrition into strategic advantage. And we will return to Richard Best's life, to the men who fixed bombs on trolleys, and to the long forensic conversation that Akagi's remains would start when they were finally found. For now, remember this: a carrier lives on discipline and design. When both are compromised by expedience, a single precise strike can become an obliteration. The shock was not merely that Akagi burned, it was that the ship, conceived as an instrument of control, became an instrument of its own destruction. After the smoke and flames had thinned into a horizon of scorched grey, naval staffs and engineers began to translate chaos into diagrams and survivors' fragments into a sequence that could be analyzed, questioned, and, to some degree, explained. The morning's physical facts were stubborn. A flight deck had been pierced, fuel had burned, ordnance had detonated, and Akagi, once the jewel of the Kido Butai, had ceased to operate as a ship. But the fuller truth that emerged from logs, interviews, and later forensic work was more complicated and more instructive than the instant image of a single bomb doing everything. Minutes and decisions, not miracles, stitched the narrative together. On Nagumo's bridge in those compressed hours, command flowed through procedures and briefings that were meant to translate scattered reports into coordinated action. We can reconstruct, almost in real time, the logic on that bridge. 7:28 a.m., the reconnaissance call, the assumption that Midway's airfields were the target, a partial launch cycle that left aircraft in various states of arming and servicing, and crucially, the rearming order that placed live ordnance and fuel in proximity on the hangar deck. That bridge work is every bit as consequential as the dive bomber's moment of release. A naval historian observing the bridge's tapes later summarized the dilemma succinctly. Nagumo was deciding between the certain inefficiency of an immediate, imperfect attack and the probable effectiveness, but higher immediate risk, of rearming his striking force. That is the cognitive landscape of command, choices under uncertainty, with incomplete information, where each available option carries strategic costs. From the American side, the choices were singular in their simplicity and multiplicity in their consequences. Lieutenant Commander Wade McCluskey's decision to follow a destroyer's wake, a small operational judgment in a complex battle space, set a chain of events into motion. He had two dive bomber divisions. They had altitude, surprise, and crucially, a clear approach. At roughly the same time, Japanese combat air patrols had been diverted low. Fighters that might have contested high-altitude bombers were engaged in other fights. The alignment of those factors gave the Dauntlesses a rare opening. Reconstructions of the attack wave show three Dauntlesses in the successful strike element on Akagi, Lieutenant Richard Best's plane, and two others whose bombs struck in close succession. The record in after-action reports and survivor testimony does not reduce those men to folk hero caricatures. Rather, it places them into a small, precise cluster of action. 3 aircraft, 3 bombs, and the physics of penetration and sympathetic detonation. According to carrier logs and pilot reports, the strikes came in a brief overlapping window. Best's hit, the one that has dominated narratives, was not alone. Multiple penetrations and near-simultaneous ignitions combined to escalate an already precarious situation. To understand how 3 bombs could so thoroughly unmake a carrier, it helps to break the incident into physical phases. First, penetration. A 1,000-pound general-purpose bomb released at steep dive angles generates significant kinetic energy. The Dauntless's design and the dive bomber technique sought to bring that energy to bear against deck plating and the hangar below. Where the flight deck was thinner, on carriers like Akagi, which retained lighter armor than some navies preferred to prioritize aircraft capacity, a sufficiently heavy bomb could punch through into the hangar. That is what the Dauntlesses accomplished. Second, ignition and fuel dynamics. The hangar was not a dry room of steel. It was a working space full of aircraft, lubricants, oils, and above all, aviation gasoline. Fueling operations involve hoses and pumps that, when ruptured, spray volatile fuel over broad areas. Fuel sprayed into an enclosed hangar is especially dangerous. Vapors accumulate, and once ignited they produce rapid high-temperature fires that can spread through ventilation, elevator trunks, and open hatches. Third, sympathetic detonation. Bombs and torpedo warheads are designed to detonate under specific conditions, often requiring a combination of impact and explosive train initiation. But when exposed to a large external fire, particularly one fed by sprayed aviation gasoline, warhead casings can heat and fail, causing internal detonation or cook-off. When multiple warheads and stacked bombs are present, one cook-off can trigger another in short order, producing multiple near-simultaneous blasts. The physical effects are multiplicative. Overpressure waves tear metal outward, structural supports fail, and the very pathways designed for aircraft and ordnance movement, elevators, trunks, and doors, become conduits for fire and blast. A naval ordnance expert explains it like this on camera. Think of a hangar as a bottle. Put a candle in it and it's just lit. Put a can of gasoline in it, then puncture the can. Suddenly the whole bottle is a bomb. Now imagine that bottle contains other smaller explosives. One ignition and the sequence runs itself. The Dauntlesses provided the first puncture. The hangar's condition provided the rest. That explanation captures the mechanics without dramatizing the human actors. The human element is present in every link. The men who left bombs on trolleys to save minutes. The petty officers who kept fuel pumps running to expedite sorties. The engineers who had accepted certain design compromises to make carriers lighter and more operationally flexible. Each choice had a rationale. Many choices were defensible at the time. The calamity arose when multiple defensible choices coincided under a shared set of constraints. On board Akagi, damage control teams attempted to apply training under conditions it had not been designed to meet. The sequence that survivors reconstructed in testimony: pumps that would not engage, vents that spread rather than contained smoke, and bulkheads that tore under blast, points to systemic failure in a moment when system robustness was most needed. A retired damage control officer observing the evidence later noted, "The crews fought bravely with the tools they had, but you cannot hold back a torrent with a handkerchief if the torrent is coming from inside the dam." Those internal detonations produced a specific pattern. Plates buckled outward, hatches sheared from frames, and elevator trunks acted as blast chimneys. Those were the physical signatures that would be examined decades later on the ocean floor. The wreck discovery in October 2019, conducted by a private expedition funded by Paul Allen's team and executed with state-of-the-art ROV mapping, offered new data points for this forensic story. At roughly 5,400 meters depth, detailed imagery and 3D mapping of Akagi's remains revealed tear patterns on upper structures and a fragmentation geometry consistent with multiple internal overpressures rather than a single external blast. Dr. Sarah Kim, a wreck forensics analyst involved in later peer-reviewed discussion of the findings, described the pattern. Outward splayed metal on the hangar roof and the localized seat of explosion engravings correspond closely to what we expect from internal cook-off sequences. The deck shows concentric patterns of stress that align with multiple, discrete detonation points inside the hull. Those observations do not assert omniscience. A responsible forensic analyst retains uncertainty. The wreckage is corroded, deformed by decades of deep-sea pressure and currents, and subject to the limits of remote sensing. Yet the 2019 imagery complemented contemporaneous survivor reports and engineering reconstructions in a way that narrowed the space for speculation. It suggested that the story so long told, one bomb, a dramatic instant, total destruction, omitted critical elements, that there were multiple penetrations and that the hangar's contents played an indispensable role. The implications of those forensic conclusions ripple outward into doctrine and institutional reform. When the Japanese Navy examined the wreckage through recovered fragments, deck logs, and eyewitness testimony, they saw procedural vulnerabilities: ordnance staging in unsecured areas, live fuel handling without full sealing, and reliance on human discipline rather than engineering buffers. Policy changes followed, both operational and technical. Arming procedures were made more conservative. The practice of staging bombs on hangar decks was curtailed where possible. Fuel handling standards were tightened. Structural changes to carrier design followed slowly, constrained by wartime pressures and resource limits. But the direction was clear. If a carrier must concentrate aircraft, the risk that concentration created had to be mitigated through design or procedure. On the American side, the lessons took a different shape. The U.S. Navy, having achieved a strategic victory at Midway, turned its attention to operationalizing the conditions that had produced advantage: superior intelligence, centralized fighter direction using radar, and industrial throughput that could replace ships and pilots. Some of those measures were tactical, implementation of more effective combat air patrol coordination, while others were strategic, namely expanding pilot training pipelines and accelerating carrier construction. The United States possessed an industrial elasticity that Japan lacked at scale. Over time, this mismatch would define the material contours of naval power in the Pacific. Yet war is not simply the arithmetic of ships and factories. It is, at every turn, the politics and personalities of institutions. Commander Joseph Rochefort, the cryptanalyst whose unit in Pearl Harbor had passed signals that foreshadowed Japanese intentions, played a critical, though complex, role in the American picture. Rochefort's work provided the clue that lured American carriers into the proper vicinity. His team's decrypts and analytic judgments helped create opportunity. But success breeds envy, and Pearl Harbor's intelligence machinery was riven by bureaucratic jockeying. Rochefort was eventually sidelined, reassigned away from the code room, a decision many historians regard as a loss of continuity in wartime intelligence management. This was a lesson of a different kind. Winning a tactical victory does not immunize an organization from internal politics, and organizational advantage can be squandered if its custodians are displaced. The human consequences of the morning on Akagi were not limited to Japanese sailors. On the American side, Lieutenant Richard H. Best, whose actions that morning have been described in both military dispatches and later profiles, paid a personal toll that extended beyond wartime medals. After returning to carrier combat, he suffered pulmonary issues that ultimately ended his combat career. Later medical histories attribute lung damage to inhalation injuries and, in some accounts, to contaminated oxygen supplies while recovering in base hospitals. A medical historian who has examined Best's file warns against simple causal chains. Best's pulmonary condition reflects a mix of combat inhalation, wartime medical environments, and the limits of mid-20th century medical care. It's reductive to say one exposure did it, but it's clear he never fully regained his pre-war health. Best retired from active service and lived out a life that rarely intersected with public celebrity. He married, worked in civilian life, and avoided self-promotion. There were no parades on his doorstep. There were, instead, quiet achievements and private griefs. The biography of a single man in these events is more a lens on the human dimension of policy and technology than an argument about decisive individuals. Best's precision in the cockpit mattered. The systems he pierced mattered more. Beyond personalities, Midway's morning reshaped campaign-level dynamics in ways that would be felt for years. The loss of veteran Japanese aircrews and carriers had a cumulative cost. Japan's institutional capacity to replace experienced pilots was limited by training time and attrition rates, while America's industrial mobilization allowed for faster replacement of material and, eventually, more pilots, albeit with varying levels of experience. The ensuing months and years show the arithmetic of attrition. Guadalcanal became a grinding test of numbers and endurance. As the Allies learned to coordinate fighters and radar more effectively, Japanese carrier aviation suffered ever more from deficits of numbers and experience. By the spring of 1944, those deficits were decisive in fleet engagements, such as the Battle of the Philippine Sea. American pilots, benefiting from improved radar control and flight training systems, inflicted catastrophic losses on Japanese carrier air wings in what pilots began to call, with grim irony, the Great Marianas Turkey Shoot. The contrast with Midway is instructive. At Midway, tactical surprise and precise action by a handful of American airmen produced a strategic shock. By the Philippine Sea, overwhelming industrial and training advantage translated into tactical superiority. The war's center of gravity had shifted. At Leyte Gulf later that year, the facade of Japanese carrier aviation as a dominant force had dissolved into strategic theatercraft. Carriers were sometimes used as decoys, and air crews were less frequently the decisive instrument of fleet projection. Losses accumulated, and the institutional capacity for carrier aviation to recover in the immediate term was overwhelmed. The arc from Akagi's explosion to Leyte Gulf's theater-level decisions is not one of simple causation, but of cumulative attrition and organizational adaptation, in which early shocks like Midway accelerated a longer trend. Returning to institutional lessons closer to the moment, Japanese inquiries into the Midway losses yielded both procedural and engineering recommendations. They emphasized stricter control of ordnance staging, improved fire suppression systems, reorganized magazine handling, and revisions to fueling protocols. But the pace of change was limited by time, resources, and the inertia of bureaucratic cultures. Institutions adopt new doctrine unevenly. Frontline innovation often rises from ad hoc adaptation rather than top-down reform. In Akagi's case, improvisation under time pressure created the conditions that innovation later tried to mitigate. There is an ironic continuity here with modern precision strike doctrine. The dive bomber's premise, deliver ordnance with accuracy at risk to the delivering platform, is an ancestor to later approaches that prioritize precision over mass. Today's precision-guided munitions seek to achieve the Dauntless's accuracy without the pilot's personal risk. But the tactical genius of precision requires institutional systems that prevent self-inflicted loss. Midway reminds us that weapons are only as safe and effective as the procedures, maintenance regimes, and institutional cultures that support their employment. Forensic work decades later continued to refine the portrait. The 2019 Akagi survey provided physical evidence that dovetailed with other technical reconstructions about blast propagation and material failure. A naval engineer speaking to the expedition emphasized how structural design choices, optimized for aircraft capacity, reduced the ship's passive survivability. Akagi was built to project air power. That required trade-offs. More hangar space and less armor meant greater operational capacity in calm times and greater vulnerability under stress. Engineers and officers made those trade-offs knowingly. The lesson: is that operational doctrine must always be matched to survivability considerations. The wreck data did not only confirm physical sequences, it also reopened historical lines of accountability and memory. Survivors had told their stories for decades, sometimes with partial recall, sometimes with clarity, and often with the trauma that memory keeps. The wreck's imagery validated aspects of those testimonies and, in doing so, restored some fragments of agency to men whose narratives had been flattened into numbers. At the same time, the data illuminated the limits of inference. Oceanic corrosion, mechanical collapse under pressure, and the absence of intact human testimony meant that wrecks are corroborative, not conclusive, elements in historical explanation. Throughout, the moral landscape of the story resisted simple verdicts. There was no single villain, no sole procedural lapse, and no solitary heroic act that determined historical fate. Instead, Midway's Morning, Akagi's destruction among its episodes, stands as a composite case, the interplay of human judgment and bounded rationality, of technological affordances and design constraints, of institutional inertia and momentary innovation. Those are the same dynamics that shape crisis decisions in organizations today, whether military, corporate, or civic. The human toll must remain central to any account. Contemporary tallies place the deaths across the carriers at more than 1,700, respectful numbers that require solemnity, not spectacle. Each numeral represents a life, and while military historians parse strategy and doctrine, the social and familial consequences of those losses are enduring. Memorials, personal archives, and the occasional survivor testimony keep alive the recognition that institutional lessons are expensive when purchased in flesh. In the decades after the war, institutional memory has been selective. Some lessons were institutionalized in doctrine and design, others became footnotes. The story of Akagi, as it circulated in naval circles and in public memory, oscillated between myth and technical reappraisal. Best name became part of that pattern, sometimes invoked as a symbol of accuracy and courage, sometimes treated as a technical footnote. The wreck's discovery in 2019 and subsequent analyses forced a renewed conversation about the interplay between human action and systemic vulnerability. What does Midway mean for present-day professional communities? It is tempting to strip the past of its complexity and recast the event as a parable. Institutional rigidity kills, frontline innovation saves. Such moralizing misses the texture. Institutional rules are designed to protect at scale. Frontline improvisation can be the source of both salvation and catastrophe. The right balance is not a simple cultural shift, but a design problem. How to create systems that are robust enough to absorb novelty and flexible enough to allow judicious adaptation. That is as true for carrier hangars and ordnance transfer procedures as it is for modern software platforms and emergency response protocols. The narrative finally returns to the men on the decks and to the quiet human afterlives that most wartime stories seldom follow. Richard Best's twilight years are telling. He lived in a post-war America vastly different from the Pacific he had known. He married, worked, and remained largely out of the public spotlight. Medical records show deterioration in pulmonary function over years, consistent with inhalation injury and the rigors of wartime service. Yet he did not seek celebrity. Instead, he was one among many veterans whose sacrifices were woven into a society that paid tribute in monuments and memorials, but not always in sustained public attention. In Japan, veterans and families reckoned with loss amid a nation grappling with defeat and reconstruction. The carriers' names, Akagi, Kaga, Soryu, Hiryu, entered memorial lists and the nation's complex narrative of the war. Engineers and officers who had once argued for different procedures found their debates memorialized in inquiries and in the slow mutability of naval design. as historians, engineers and forensic analysts sift the layered evidence of Akagi's demise, a set of recurrent lessons emerges. Systems fail at their seams where design compromises meet human pressure. Innovation matters, but its adoption is often delayed by organizational friction. Physical evidence, when recovered and properly interpreted, can correct or confirm human testimony, but it rarely tells the whole story alone. And above all, the human cost remains the anchor. The numbers are solemn reminders, not abstractions. The shocking story of how 3 bombers obliterated Japan's Invincible Akagi therefore carries a dual truth. The shock is real. Penetrating strikes by a small set of aircraft found and exploited an operational vulnerability, and the resulting internal detonations and fires unmade a carrier. The shock is also contingent. It required procedural compromises, design trade-offs, and the misalignment of protective practices under stress. To call the event shocking is accurate. To treat it as a mystery resolved by a single heroic act would be to misread a far more instructive and far more human sequence. We end as the ship ended, not in a triumphalist blaze, but in a complicated, costly lesson. Wreck forensics and archival documents have converged to paint a picture that is both technically precise and morally complex. The 3 Dauntlesses that morning accomplished what their training promised. The ship's internal conditions amplified their effects beyond what either side might have predicted. In the long sweep of the Pacific War, Midway's morning and Akagi's fate helped tilt operational realities in favor of a nation whose industrial might and doctrine would, over time, convert tactical advantages into strategic dominance. For viewers who have followed this close reading of minutes and mechanisms, the next layer remains to be explored. The code room rivalries and the bureaucratic shifts that followed, the industrial mobilization that converted learning into mass, and the small personal stories, both Japanese and American, that the archives still preserve. Those are the tissues that flesh out the anatomy of a naval turning point. If this account moved you, or if you have questions about the forensic details, the ordnance mechanics, or the human stories we touched on, leave a comment with what you want to see next. In the next installment, we will examine Joseph Rochefort's role in the intelligence picture in depth, trace the bureaucratic consequences in Washington and Tokyo, and follow how the lessons of Akagi's destruction reshaped campaigns from Guadalcanal to the Marianas. For now, remember that history's shocks often emerge where small decisions, design compromises, and moments of improvisation meet, and that the cost of those shocks is measured in lives and in institutional memory. If you'd like to continue, subscribe, and join us for the next part of this series, where we go inside the code room, the ministerial debates, and the shipyards that tried to rebuild the future on the ashes of Akagi.